Hello, everyone. Hope you all have been having a great GopherCon so far. My name is Jessica, and I am going to be speaking today about how GitHub standardized our usage of Go. And I'm hoping that you'll get two things out of this talk. First of all, I hope that I can convince you that standardization can be a good thing. And secondarily, I'm hoping that there might be some takeaways from the process we went through for anybody who wants to do something similar. And I also have a quick disclaimer. Since this is a shorter format talk, I'm going to be going more for breadth than depth in the information that I'm providing. And before we get started, a quick blurb about myself. So my name is Jessica Lucci, and I'm an infrastructure engineer at GitHub. I've been at GitHub for about 2 years now, but I've been doing ops type work for about 7 or 8. And the reason that I got into ops initially was that I'm really passionate about making the lives of other developers easier. This means that I'm always on the lookout for ways to add or improve tooling in processes or what have you, anything that makes other developers' jobs feel more seamless. Crushed it. So when I recently had a bit of a hard time setting up a new application, I wanted to do something about it so that other developers wouldn't have to have the same difficulties I had. And here's what happened. I was tasked with building a fairly simple application, a small scraping job written in Go that pulled some data from an API and saved it into a data store. The API was already set up and running, so I decided to the first thing I decided I wanted to work on was setting up a schema for the new database. This was the first time I had set up a database or a schema at GitHub, so I figured I'd ask around to see what the standard for these kind of things were. I asked a couple different teams and got a whole range of answers from we save our schema in a text file, which is always a super exciting thing to hear when you work in ops, to we manage it directly in code and everything in between. I eventually got in touch with our database team to clear this up, and it turns out they had actually written their own schema management tool that they wanted developers in the company to use. This was a new tool to me and to a decent amount of engineers in the company, so I spent some time learning how to use it and writing up automation around local development and testing. A few days later, and a few bash scripts later, we had a new database, and it had a fully managed schema. So with all of that buttoned up, I decided I wanted to start working on the database driver. Turns out I had never actually had to choose a database driver for a project before. I had only ever iterated on existing ones. So I reached out to other Go developers at the company to see what they were using and get any suggestions they might have. I got more than a few suggestions, all of which came with pretty compelling reasons. But it was apparent there wasn't a standard in the company for this kind of thing. So in order to make an informed decision about what driver to use, I spent some time learning and evaluating different driver modules. I eventually landed on one that seemed like a good fit for our project. So once again, a few days later and many integration tests later, we had a driver and a new set of tests for local development, integration testing, updated docs, the whole shebang. So all that was left to do was to build this API client for the application. And I'm assuming at this point you can guess how that worked out for me. Checked in with different teams to see if there was a standard client we were using, found out there wasn't, researched viable options, and we ended up writing our own client. So eventually the application was finished, but this was something I assumed was only going to take me 3 or 4 days to write, but ultimately ended up taking 3 or 4 weeks. And unfortunately, this wasn't a unique experience at GitHub at the time. So I got together with a few other developers who had gone through more or less of the same thing, and we chatted about what we could do to improve this experience. And what we landed on as a solution was this idea of language standardization. So what do we mean when we say language standardization? Well, we came up with 3 main tenets for defining what that meant. The first was the standardization of libraries and packages of code used in applications. The second was the standardization of applications' project structures. And the third was the standardization of an application's development lifecycle. Let's get a little more into detail about what each of those really mean. Standardizing libraries and packages essentially meant standardizing what versions of what code should be used in applications. And in order to decide what versions of what code should be used, it was important that we introduce a process for evaluating potential new packages, as well as a process for reviewing changes to existing approved packages. Something else that was really important for this piece to come together was that we have a defined way to automate upgrades of any of the common modules that were being used. And lastly, all of the packages for a given language needed to live in a centralized place, so developers only had to go to one spot to look for available code. By standardizing project structure, we wanted to be able to answer the question, where do I find the thing? We wanted developers to be able to go into an entirely new repository and know exactly where to find whatever it may be they were looking for. We hope to accomplish this by, firstly, standardizing what the project's code directory looked like. So, for example, in Go alone, there's many different approaches for structuring a project. I've seen people use a flat directory approach, I've seen people use domain-driven development, and many more styles. But by converging on a single layout, we hoped it would make it easier for developers to move across different projects in the organization. Additionally, we wanted to standardize the directory structure of non-code parts of a project. So this would be things like where config files might live, or where build and run scripts might live, if we even wanted to use those kind of scripts. By knowing where all the pieces of an application lived, we hoped it would be easier for developers to also understand how all of those pieces fit together in an application's development lifecycle. And by standardizing on the development lifecycle itself, we wanted engineers to be able to easily answer the question, how does this thing get into production? And there are a lot of things that go into that idea, but we chose to focus on a few initially, including Git workflow. So things like, should devs be deploying off of master? How should we be merging pull requests? Local development. How should we be running applications locally? Should we be using Docker, or should we have engineers install Kubernetes directly on their laptops? CI/CD, what technology should we be using to run our builds? And what builds should we be running for a given application? And lastly, logs. Where should an application write its logs to? Where can a developer expect to find logs once an application is running in production? Again, there are many, many pieces that go into an application's development lifecycle, but these were a few of the things that we thought were important to get started. After we had come up with what standardization meant, we had to make a case for why it was important to enact those standards. And we came up with three main reasons. The first was to improve security and trust. The second was to improve discoverability and reduce duplicated efforts. And the third was to promote consistency that would organically drive collaboration. So the driver that I had ended up using in my application, it turned out the version we had deployed had a pretty serious security vulnerability. And a different team using that same driver had actually found that vulnerability about a week before we deployed our application to production, but it was still about another week before our team was even made aware of it. This was obviously a somewhat less than ideal situation, but the good news is that had we had our standardization processes in place at the time, things could have been a whole lot better. For instance, if our system for auditing and reviewing libraries was in place, even though I had missed the bug in my own initial evaluation, someone else in that review process might have caught it. If we had automated updates ready to go, when that other team had identified and patched the bug, that fix would have automatically been pushed to our project before it had even hit production. And lastly, if everyone was using a single driver library, there would be a lot more people using that driver library in production. But they would all be using it under different loads and in different ways. So any bugs or flaws in that driver probably would have come up before we deployed our app. Having wide usage of any given library in production increases developer confidence in that library and their decision to use it in their own project. Thinking back to the story once more, remember it was about a week before I had found out that our database team had written the schema management tool. Well, quite honestly, using the search mechanisms we had in place at the time, it could have been a lot longer before I had found it, if I had found it at all. But by consolidating blessed packages for a language into known central locations, answering the question, what packages or tooling for this purpose already exist, becomes fairly trivial to answer. Granted, this was going to take some measure of intentional naming and organization to make it clear what the purpose of a given library was, but just the act of consolidation made discoverability so much better than what it had been previously. We also wanted to make it clear what libraries were production ready to make it easy for developers to choose which ones to use in their own projects. I spoke earlier about how we ended up writing our own API client for that application. What I neglected to mention was that I had actually found 3 or 4 clients that my coworkers had already written for this API. But each of those clients were in various states of completion, upkeep, and usage. So I, in my infinite wisdom, decided that since I couldn't easily verify that any of these clients were production ready, the best solution was obviously to write my own version that was. And that worked out about as well as you thought it did. Instead of creating a new standard client for this API, I had only succeeded in creating one more client in the list of contenders. If we had had a single client that was known to be production ready, I instead could have contributed whatever functionality was lacking for my application to it, rather than duplicating all of the engineering time and work that had already gone into creating it. Lastly, and in my humble opinion, the most compelling reason to adopt standardization was so that we could increase consistency across repositories. We wanted to make the experience of switching between projects as seamless as possible for all developers. By standardizing on a set of common libraries, as well as a single known process for getting applications from development into production, things like contributing, debugging, and deploying any given application in the organization became a whole lot easier. And by making the experience of interacting with any application more consistent, we inherently promoted collaboration between projects in the engineering org. And GitHub is, at its core, a platform for collaboration. We believe that projects are made better when they're crafted with a diverse set of ideas and backgrounds and inputs. And anything we can do to foster that kind of collaboration is not only great for our engineering organization, but ultimately benefits anyone using the platform. And after we presented that argument, it was pretty hard for our managers to say no, so we were given the go-ahead to proceed with implementing standardization. And we eventually came up with 2 initiatives to do this work moving forward. We started something called the language working groups, and we hired on framework engineers. Language working groups were groups of volunteer engineers, each of which had some level of familiarity, expertise, or interest in a given programming language. These groups met every other week or so to start implementing different pieces of standardization. While there were a lot of parts, the things we initially focused on were CI/CD, figuring out what builds should be run for what languages. This work also included defining a scorecard for each language. Those scorecards were filled out at build time using static code analysis and were reported up to our SLO dashboards. We also focused on module vetting. So this was identifying and evaluating all of our current internal modules. We focused on upgrades, which was bringing both the language versions themselves as well as the module versions of all projects up to date. We also focused on creating process. So creating formalized processes around module reviews, feature proposals, bug reports, etc. And lastly, we spent a lot of time working on updates. This was building a system to push module version updates to all projects. We wanted to do this using a pull request-based model. And the reason for that is we actually already had a system in place for other kinds of org-wide project updates that used this model, and it was working really well for us. So in the spirit of standardization, we wanted to take advantage of that existing tooling. We also hired on a set of framework engineers. These were people who were experts in a given language and who worked full-time on the standardization initiatives. While we were working on implementing standardization, we did run into a few challenges. These included getting buy-in from other engineers, migrating existing systems onto the new standardization platform, and securing resources to implement the standardization. GitHub has an amazing engineering culture of autonomy and innovation. We trust our engineers to make the best decisions with the context that they're given. So the idea of standardization and restricting what technologies someone can use or how they can use them was not the easiest sell. We couldn't just barge in and tell everyone this is the way the world is now. We had to come up with ways to get people genuinely excited about this work. So the first thing we did was spend a lot of time evangelizing this effort. We met with other developers and explained why we were doing this and why we thought it was so important, really working on bringing this understanding to the engineering org about the value of standardization. We were also very intentional about creating an open dialogue about this effort. We made sure we had well-known venues for other developers to voice concerns, provide feedback, and test out new features. We provided consistent updates to the engineering organization through emails, blog posts. We also did video demos and held workshops, anything we could think of to share status. And lastly, we spent a lot of time automating as much of the migration to these new standards as we possibly could. In our extensive research, we found that developers tended to be a lot more enthusiastic about switching over to new technologies when it didn't require them to do anything. Speaking of migrations, we did run into a few challenges during that process. The first of those challenges was migrating to modules. So Go 111 came with an exciting update to dependency management in the form of modules. Modules were, at the same time, however, a major shift away from existing practices and tooling in both the Go ecosystem, but also in how we did Go at GitHub. So we ended up deciding to hold off on updating our common tooling to the module ecosystem until the release of Go 112. And this gave us time to teach other Go developers at the company about what modules were, how to use them, and how they might migrate their existing projects to this new framework. It also gave us some time to work with the Go community and within our language working groups to iron out any wrinkles in the new system. Also, prior to modules, we were using a vendoring system for packaging and building our Go applications. This meant that all the necessary source code to build an application lived in a vendor directory alongside the application itself. So when we switched over to using modules, we had to find a way to now install dependencies at build time. Go proxies are a wonderful tool to help achieve this, and so that's what we decided to look into. At the same time we were working on this initiative, there was a separate initiative at the company to migrate all of the build artifacts at GitHub into a centralized system. And once more, in the spirit of standardization, we decided to use that system. Unfortunately, it had been constructed in a way that only allowed it to contain private artifacts. This meant we couldn't just point a Go proxy at it because that proxy wouldn't have access to any of the public modules we needed. It would only be able to serve our private ones. Also, unfortunately, none of the viable workarounds we had for this we felt were secure enough to move into production. So we're actually still working on figuring out ways to update this system so that we can use it for everything. But in the meantime, we had to add authorization to all of the existing Go CI builds so that they could perform Go Git operations directly. These builds also relied on a set of Go tooling. With the move to modules, coupled with our standardizing on a set of Go packages, we needed a way to ensure that every project was getting the standardized version of whatever tool it was using in those builds. The Go FAQs actually have some really great suggestions for this. Those solutions were not quite as transparent from a user perspective as what we were aiming to do in the language working groups. So we spent some time figuring out how to do this in a seamless way and eventually landed on a solution that required minimal change in our existing projects. Since we had already standardized on the set of builds that would be run for a given Go project, and we had finished writing this pull request update system, we used that system to push out a new bash file that automated the install of pinned versions for tooling in those standardized builds. Then, all that was required for an application to move on to standardized tooling was for someone to accept and merge the pull request we had pushed out. So the last challenge we ran into was resources. As I mentioned earlier, the language working groups were comprised only of volunteer engineers. These were people who had gotten approval from their own managers to spend a couple hours a week working on this initiative. However, they were still responsible for working on their own team's deliverables, and that took priority over the work we were doing. The end result of that was we weren't getting a whole lot done. This was when we started playing around with the idea of hiring people on full-time to help with these initiatives. We came up with the idea of bringing on experts in each language and created the framework engineering roles. As these roles were filled, we saw an immediate uptick in productivity, not only because we now had someone working full-time on the initiative, but also because each part of the initiative now had clear ownership. We also found that we seemed to be doing a whole lot of work, but not always necessarily having a whole lot to show for it. And we found that this was because we were treating this initiative a little too informally. We didn't have clear goals with deadlines. We mostly had aspirations. So we got together and defined roadmaps for the different pieces we were working on and got each of those formally added to the engineering organization's OKRs. Once this was in place, we were able to clearly map work to deliverables, and we saw the team's productivity increase. So we've done a lot of really great work on standardization, but there's still a lot we want to accomplish. So in the next quarter, we're hoping to make some progress on both finalizing our internal package registry updates so that we can start using Go proxies. And we're also looking to create more formalized support around things like reporting bugs and requesting new features in the language working groups. And lastly, because we've seen so much success on standardizing on just languages, we're hoping to roll out similar processes to things like standardizing Kubernetes configs or network policies. So we're really excited about that. And that's all I have for you today, but thank you all so much for being here and having me, and I hope you have a wonderful rest of your GopherCon.